We are using our Raspberry Pis today. I had a question about that. From now on, assume that you are using the Raspberry Pi unless otherwise notified. So, yeah, no school tomorrow. I hear a lot of no school tomorrow. That's very exciting. Okay, if you can't tell, this school teacher is a little bit jealous that there's no snow this far south. But I hope you guys are enjoying your school days. Very, very exciting. Okay. The version of Scratch that we're using on Raspberry Pi today is not the same as the version if you just go to scratch.mit.edu and hit Create. It's a special version, the 1.4 version, and you actually download it on your computer. And on Scratch, it's already downloaded, it's already installed. So if you do not have a Raspberry Pi for whatever reason, you can go ahead and download this Scratch version for whatever operating system that you are using. So what I'm going to do, I'm going to post this on Edmodo later, and I'm going to go ahead and send it out in chat. But I will be moving ahead today with the lesson, and you can watch the recording if need be and get caught up on some of these basics. Okay, I'm seeing some people say, I don't have my Raspberry Pi. Yes, you can go back and watch the YouTube video. That option will always be available for you. Sometimes if I think that, sometimes I will post one YouTube video of the class that went really well if we covered the same material. So, and then sometimes I'll do class specific if we covered different material. I just mean there's a webinar at 7 p.m., your guys' webinar, and a webinar at 8 p.m. It's the same class. So if we cover different material, because they are in 7th and 8th grade, there'll be 2 YouTube links. If we cover the same material, sometimes I might just choose one, the one I think that maybe I spoke clearer. I only say that to clarify if you were confused, because I know on Edmodo I only sent out one link, and if you went to the YouTube for Monday, I only sent out one link, but if you missed Monday, that's the link to go to the webinar to get caught up. So I sent this out. This is the installer in case you don't have your Raspberry Pi, but you still want to practice with the 1.4 version of Scratch. Not the regular Scratch that you would use by just going to scratch.mit.edu. This is an older version, and you download it as an application on your computer, like so. Okay? So we're going to be going through this today and learning some of the basics. It's beneficial even if you have studied Scratch before, since this is a different interface. And we're going to be using Scratch in order to do some really cool things, like physical computing, interacting with the physical world with LEDs. Glad everyone's got new equipment. We're going to go ahead and get started. So if you're on your Raspberry Pi, open Scratch on your desktop. The little cat program right here. And you should get an interface that looks very similar to this. All right. Hear you. Okay, that's fine. So, oh, we're going to go ahead and move forward. Well, raise your hand if you do not have Scratch open yet. All right, we got a few people that don't have Scratch open yet. We'll give you another minute or two. That's okay. If I'm gonna ask, if you're gonna follow on YouTube, then yeah, when I ask, do you have Scratch open yet? You don't have to raise your hand because I'm asking people to raise their hands in case you know, they want me to wait. And as soon as you're ready to keep going, please put your hands down. We're just waiting for our classmates to pull up Scratch. While we're waiting, I can go over kind of why we're learning Scratch, or a little bit about Scratch for those of you who have never used Scratch before. Moments. I'm getting some updates that it's just moving very slowly. Alright, so just waiting on 2 more hands. As soon as you have Scratch up, please put your hand down. Alright girls, keep loading up your Raspberry Pis. I am going to have to move forward with the lesson. Shoot me a message if you're having trouble and I can help you troubleshoot in a little bit. But you can always go back to the recording if you miss a little bit from the beginning. So Scratch is a programming language developed by MIT for kids age 8 to 80. That's what they advertise as. And this is actually used in MIT's Intro to Programming classes. So it is fairly sophisticated. It's used by Harvard students in their Intro to Programming classes. Even though it might seem like a little young with the cat and the puzzle piece graphics, you can actually do truly incredible stuff with Scratch. It's fun and powerful, and it's free, which I think makes it very powerful because it allows anyone with access to a computer. They don't even have to have their own computer, but access to like a library computer can use Scratch, which is great. You can create content like stories or animations, and also games where the user can interact with the graphics, and the graphics will act out the code that you give it. So we are using version 1.4, as I have said. For maybe those of you who are just getting here, we are getting the version that comes with the Pi, 1.4. It's actually downloaded on your computer. It is not version 2, and this is a screenshot from version 2. Version 2 requires the internet, and you don't actually download the program onto your computer. You do it all through a web browser like Chrome or Safari or Internet Explorer. Okay, so as I said before, if your Pi's not working and you don't have a monitor and you're kind of waiting but you want to keep up with class, I sent out a link at the beginning of class, and I will post this link on Edmodo as well, to download Scratch 1.4 onto your laptop or desktop computer. And you can follow along that way. But again, you'll most likely have to do that after today's class and catch up with the recorded version. And you can follow along for today. We will not be using version 2.0. It does not come with the Pi. So at this point, you all should have, all right, I'm looking at the hands. I'm going to put your hands down. Azelle, is there a reason that you have your hand up? I know you don't have your Raspberry Pi. That's okay, Azelle. You can follow along with the webinar today and get the Scratch version, the 1.4 version, and put it on your computer, maybe after class today. So from now on, I'm going to be working on the Scratch application that I already put on my computer. Looks like so. And then I want you to watch what I am doing, and then I will let you know when I want you to try it on your own. But when I want you, for the most part, to be watching my screen, and then when I kind of give you the go-ahead, you'll try it with your Scratch. Does that make sense to everybody? Any questions on that? Okay. So, yeah, you're going to most likely need a keyboard today and every day. It's okay if you don't have one. Try to do as best as you can, but to change the numbers in here, you would need a keyboard. Alright, so this is the sprites area. Your sprites are your little characters, and each character that you can add your own script or sequence of commands for that sprite to follow. And you're going to see that sprite follow those commands in the stage area, and this white background is the staging area. So here's your little sprite. Again, please be paying attention to my computer screen for right now, because this kind of upfront information is really important so that you guys know the different areas that I'm talking about. And then in a little bit, I'll let you try it on your Scratch, on your programs. So again, this is my my sprite. I only have one sprite in the sprite area right now. This is the stage. This is where the sprite will act out the sequence of commands that I give it. And I kind of make that sequence of commands in this area. This is your scripting area. And you pull blocks from the block palette into the scripting area. And we're going to try that right now. We're going to pull, we're going to click on Control. Notice when you click on these different categories in the block palette, the blocks change. So watch my screen first to see where I find these blocks, and then you guys can try it out. You're going to click on the Control category and pull out the When Green Flag is Clicked block and just drop it onto this scripting area right here. So everybody go ahead and do that. On the Control block, or in the Control category, find the When the Green Flag is Clicked block, and this is called a hat block because it's the top of a sequence of commands. And you're going to click and drag it into the script area and release. Alright, go ahead and bring your attention back to my screen. So I made a mistake. I added 2 When Green Flag is Clicked blocks, 2 hat blocks to my screen. The way that I can get rid of this second hat block would be to right click it and select Delete, or to click and drag it over to the block palette area again. And when I release, it just disappears. So everybody go ahead and practice that. Drag an extra block into the scripting area and then go ahead and get rid of it. Everybody practice that. Again, so you have an extra block, and you can either right click and select Delete, or click that block and drop it over back into the block palette, and that will delete it. It's like putting a block back in the box. Now, as a reminder, right now in the script area, I'm building a sequence or a list of commands that this sprite is going to act out on the stage. So I'm going to click attention on my screen for a minute. I'm going to click the Motion Blocks category. It's the top left in my block palette. And these blocks look a little different, notice, than this hat block. These blocks are called stack blocks, S-T-A-C-K. And these are going to be, most of your blocks are going to be these stack blocks. They go under hat blocks, so we're going to add this one right here. And notice when I pay attention to my screen, don't try to do this quite yet. I'll let you know when I want you to try. But you're going to grab the Move 10 Steps block, and you're going to click and drag it until you see that white line, and that's letting you know that it's going to fit together with that hat block. Alright, and before you give that a try, I want to kind of explain what's going on here. So the hat block, the H-A-T hat block, this yellow block, is going to tell ScratchCat when to start the list of commands that you're giving ScratchCat. That's my name for this guy, ScratchCat. So what this is saying is when the user clicks this green flag, you need to start doing the list of commands beneath it. Scratch is what's called a top-down Scratch has a top-down flow, which means that if I add several blocks, it will do the top one first, and then the second one next, and the third one after that. But for right now, I want you guys to go back to your screens and click the Move 10 Steps block under the Motion category and snap it to your when green flag arrow is clicked hat block so that they're together. And then go ahead and click on that green flag. Yeah, it is. It's like a virtual puzzle. Ingrid pointed that out. And it really is like a virtual puzzle because a lot of times you're trying to solve these really complex questions. In order to make a game, you have to think about these challenging game sequences and break it down into really easy steps. And Ingrid, we're going to take a look at that a little bit later when we make the Pong game. But it seems really daunting. It seems like making the Pong game is going to be really difficult to do. But if you just break it down into these manageable steps, well, how do I make the paddle move right when I hit the right arrow key? Okay, now I have that working. How do I make the paddle move left when I hit the left arrow key? If you break it down into those manageable steps, it really is just a little puzzle. That's why in order, to be a programmer, of course it helps if you are smart. It helps if you're a really smart student. But what's most important is that you work hard. A lot of times people who have had things come really easy to them in school stumble a little bit when they get to programming because you got to work hard at it. A lot of times you got to really think and brainstorm for a solution. All right, but let's figure out how to get this cat to move. Okay, let's get back to this specific example. I kind of went off on a little bit of a tangent there. So when I click the green flag, the cat moves forward, quote unquote, 10 steps. And really what this means is that the cat icon, or this little sprite guy, is going to be moved 10 steps in whatever direction the cat is pointing. And we know which way the cat is pointing. Everybody, eyes on my screen. We know which way the cat is pointing because of this blue line up here. So if I have cat, if I do the rotate, whoops, that was weird. Oh, those were two different settings I was doing. I apologize. Notice though that when I do click this button, which is a special setting that we don't really have to worry, when I click it and the cat flips around, that blue line flips around as well. So if I did have the cat moving in the other direction, let's say I'm going to have the cat point upwards, and I'm not going to ask you guys to do this, I just kind of want to show you this. Now when the green flag is clicked, notice that the blue arrow, that blue line is pointing up. So when I click the green flag, the cat now moves upwards. And you can actually just click and drag that little blue line up here to change the way the cat is oriented. Does everyone see how I'm doing that? All right, go ahead and try it on your own screen. Make the cat be pointing downwards and then have him move down the screen. Your cat walked off the screen. Oh no. Okay, someone said that their cat walked off the screen. Silly cat. The center of this stage, so everybody eyes on my screen for a second because this is really important. The center of this stage is 0, 0. like the XY axis, which you're going to get to in math class. I don't think quite this in the next couple years, but you will get there. For right now, all you need to know is that that center point right there is 0, 0. It means that, let's see. We're just going to go with that for right now. So you can pull that, go to X0, Y0 block. You can click and pull that into your script area and just click that single block. If you ever lose your cat because he walked off the screen, like so, all you have to do is go to the motion section, find the go to 0, 0 block and click it. And that's just a one block sequence, one command for your cat to follow, and you can delete that block. Alright, what I want everybody to do for me, so watch on my screen and then you go ahead and do it in your screen, is pull the point in direction 90 block and pull it onto your screen and then click it. And now Scratch Cat is pointing in the right direction. You can then delete that block. So go ahead and do that. Pull the point in direction 90 block onto the screen, click it, and then you can get rid of that block. Valerie, I'm glad that you are joining us. We got a new classmate this week. Valerie is joining us, and I'm so glad to have you here. I just now saw that you were joining us because you asked a question, and she asked a great question about a block that she sees down here, if on edge bounce. Uh-oh. I think it looks like her keyboard's not quite working. And we will get to this block actually either later today or on Monday, but for right now, we're going to be doing some really simple code as we learn. Okay. Eyes on my screen, off of your screen. So what we're going to do right now, because as exciting as this is, it's kind of annoying to have to sit and click that green flag every time. I'm going to click the Move 10 Steps block, oops, and drag it away from the When Green Flag Clicked hat block. I'm going to refer to this as the hat block from now on. And the name is just too long. So the hat block, or the green flag block. And I'm going to go into Control and find this odd looking block. It kind of looks like the letter C. Right, your eyes should be on my screen right now, and I'll let you know when I want you guys to try this. And you're going to pull this repeat block in here. And you can almost see here, who said that this was like a puzzle? As Ingrid pointed out, it's a virtual puzzle. So this piece can actually fit within the repeat 10 piece. And what this does is it's going to repeat whatever within these yellow bars, however many times you tell it. So you could say, have cat move 15 steps, and the way I did that was just click in here and change. And you could have it repeat however many times you like. Okay. The other thing I'm going to do is add a go to block 0, 0. And the reason that I'm going to do that is because I'm going to actually do that before this repeat block with the move 15 steps, is I don't want the cat to run off the side of the page. So now what's going to happen is every time I click the green flag, the cat's going to go to the center of the screen and then move 15 steps, move 15 steps, move 15 steps, etc., 10 times. All right, I know I just gave you all plenty to do. Go ahead and try that out. And if you have a question, let me know. I am going to start asking you a couple questions from now on. Oh, your cat typed that. Annika was probably trying to chase Scratch Cat. Someone pointed out a really good point. When Scratch Cat walks, he does not change his feet. And that is absolutely correct. He does not change his feet. That's because he's just one flat image. And when he moves 15 steps, Scratch does not understand that this is a cat. This is something that humans would have walk. Scratch reads this and says, okay, what you want me to do is take this image and move it along the screen by 15 pixels, which is like a measurement on a computer. You know how we use like inches or centimeters? On a computer, you talk in pixels, and they're very, very, very small. So what this computer is saying is, okay, you want me to put the image in the middle of the screen and then have it move to the right 15 times, or 15 pixels, then move 15 more pixels, then move 15 more pixels, etc., etc. If we want to make it look like Scratch Cat is moving, we have to add that in there ourselves. What we have to do is change the image, and we can actually take a look at that right now if you want. Valerie asked a very good question. And Valerie, I actually just want you to try it out, and I want everybody to try it out. What would happen if we included the go-to x0, y0 block within the loop? Let's go ahead and try it out. It's not super interesting. So I know I see a lot of questions, and I'm going to go through them all, but everybody take a moment to try this out or look at my screen, and then either raise your hand if you know what's going on, or type me a response or a guess if you think you know why Scratch Cat's just kind of freaking out when we run this code. Azelle, I am saying the sprite is just a 2D form. That sprite could be anything. It could be a square. It could be anything. It does not matter to the computer. The computer doesn't see that this cat has 2 legs and that they should be moving. Okay, so who has an answer to Valerie's question? Let's see, Azelle has an answer. He is going, but is then moving smaller than pixels. Not quite. You do notice that he is going, so that was a really good guess, but he's moving the right number of pixels. It's really important to notice that if your code does not work how you expect it to, it's working correctly, you just didn't type the correct code. You know, 99.9 times out of 100, the computer is doing everything correctly. You just told it to do the wrong thing. That's called a semantic error. Someone says, since it says go nowhere, Scratch Cat is confused. Well, Scratch Cat really isn't confused. You know, this Scratch Cat is doing exactly what you're telling him to do. Mira has a really good answer, and I see that Holly is raising her hand. So Holly, I'm going to call on you, and then if Mira wants to help you out in a minute, that's great. Hey Holly, what do you think?
He's moving the 15 steps, but then moving back to the center, so he's just sort of going back and forth really fast.
Perfect, awesome, and I think that's exactly what Mira said as well. So great. So Scratch Cat, what's happening here is that both of these commands are being repeated 10 times. So when the code starts, Scratch Cat goes to 0, 0, the center of the screen. Scratch Cat moves 15 steps to the side, and then the loop repeats. goes to the center of the screen, moves 15 steps to the side. Repeats again and again and again. Someone says they can't hear. Raise your hand if you can hear me. Okay, great. Sorry, Azelle, I think it might be on your end, but you can't hear me, so let me type that out. Oh, no. Okay. Alright, so what we're going to do now is, let me check. Someone was interested in having Scratchcat move, and I think this is a really good time to talk about costumes. So I'm going to go ahead and change my code back. Notice how when I grab the inside of this loop, both blocks kind of come out in my hands together. That's because when you grab a sequence from the top, let me stack a bunch of blocks on top of each other. When you grab the top block, you grab all the blocks beneath it. So if I wanted to remove the middle block there, what I would do is I would grab it, and then I would grab the one beneath it, and stick those back together, and then delete that one. Okay. I know that may have been a little bit confusing to follow, but you'll get the hang of it as you do it. Just know that when you grab the top block, it grabs all the blocks beneath it. Okay. So eyes on my screen. We're going to take a look at costumes. Now, Scratchcat comes with two costumes automatically. Costume 1 and Costume 2. And it kind of looks like Scratchcat is skipping, right? Uh-oh. Oh, oops. I double-clicked one. That was the issue. Okay, so these, again, I was in my script editor, and your eyes should be on my screen right now. And I hit Costumes, and it let me see the two costumes that were built into Scratchcat. And what this does is it just changes the image that your user can see. It's still the same sprite. It's still going to follow the same commands that you give it. It just looks different. Well, and you refer to those different looks, like those different images, as the costumes. So I'm back in my script editor. Everybody's still eyes on my screen. And now I'm going to add next costume into my loop. So now, when the green flag is clicked, the cat will go to the middle of the screen, move to the right, change costume, move to the right, change costume. And when I mean change costume, I mean a new image is going to kind of pop up. So when we do that, what it looks like is Scratchcat is kind of skipping. One issue is that Scratchcat is skipping super fast. Faster than we can see, pretty much. So I'm going to add one more block from the control unit. Eyes should still be on my screen, and I will repeat this when it's your turn to do it. I'm going to pull the wait 1 second block. Notice too how these blocks are yellow and the control up here is yellow. That can help you find the blocks when it's your turn to make the code. I'm going to add a wait 1 second block below the next costume block, and I'm actually going to change it to 0.5 seconds. So now, kind of looks more like Scratchcat is skipping along. Go ahead and try this out. Within your loop, you're going to have the Scratchcat move to the right, switch whichever image, and then wait a moment. And we can talk a little bit more why he needs to wait a moment. But pretty much it's because the computer is processing the commands that you're giving it so fast, it's processing it faster than our eyes can see. The sprite is not basically part of the script. The sprite is very different from the script. The sprite is the visual representation of what your script is doing, if that makes sense, and I don't think it did. The sprite is going to act out all of the commands that you give it, that the script, the script is the commands that you give the sprite. He does. He looks like he's running. If you click both really fast. Oh, that's funny. I am in costumes when I pressed the green flag and I saw it switch costumes. I don't know what that means. I'm sorry. You want your code to look kind of like this. Here, I'm going to put everyone's hands down. Ingrid, if it's working, that's great. If you have a question, could you rephrase that question? I didn't quite catch what you were trying to say. All right, so again, this is what you're trying to do. And what I did here is I added a next costume block beneath my move 10 steps block and a wait block below that next costume block. Now I have a challenge for you. The first challenge is I want Scratch Cat to move further to the right every time he moves. So what could you change about this blue block, this move steps block, so that Scratch Cat ends up over here? Scratch Cat ends up further to the right. What could I do? Oh, great, I have someone. No, hand went down. Hands back up, of course, as soon as I, Valerie. What you think, Valerie?
You could change the move 10 steps to move 15 steps or more to make it move farther each time.
Great. You're increasing the number of pixels. And Valerie, do you want to say hey to your classmates? I should have introduced you at the beginning of class.
Oh, hi. My name's Valerie.
We're so excited to have you. I'm glad that you could join us tonight. All right. I'm going to mute you. Okay, so what Valerie suggested, we change this to move 15 steps. And I'm actually, and what I just changed was the move however many steps. And I'm actually going to change this top block too, this go to XY block. I'm going to say that it should go to, in that first white space, I'm going to say -100. And I'm doing that because I don't want Scratch Cat in the center of the screen. I want Scratch Cat kind of further over to the left so that he has more space to move. And that increased how long his step was. If you made it 50 steps, it's a lot more noticeable. Now he's galloping. Any questions on that? Yes, the next costume block means if you're on costume 1, move to costume 2. Or if you're on costume 2, move to costume 1. All right, everybody, I have something I want you all to do. I want you to take a look at my screen. I want you guys to come up with your own dancing script. So this is what mine's going to look like here. I'm changing it. I'm making this number more negative, this x number more negative, because, and this is explaining an xy plane, which I know that was a little bit further in math class, but I know you guys can get the hang of it. Let me explain what this looks like. Or maybe not. Oh, okay. Valerie has a really good question. Azelle, I'm not quite sure it represents the costumes is not really a script. We can talk about that more in a little bit. Can we make our own costumes? Yes, that's what we're going to do, Annika. Valerie had a really great question about costumes, so we're going to take a look at this. Whoa, 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 not that. In math class, you are going to be plotting functions. It's very exciting. Valerie, I know you just joined the class. I am a big math person. I love math. And so this is, makes my day. It's XY plane. But in Scratch, it's really simple. This would be the middle of our Scratch board. And basically, we can take a look at these numbers that x is going to equal. And when we talk about this x value, we're talking about this horizontal line in our screen. If we want our sprite to be near the right of the screen, we make our x values large, close to 250. If we want our sprite to be on the left side of the screen, we make our x values very, very negative. So like negative 250. If we want our sprite to be high on the page, we make our numbers, our y number, really, really big, like positive 250. And if we want our sprite to be low on the page, I bet you guessed it, we make our numbers very, very negative, so negative 250. So let's take a look at that. Eyes on my screen, please. If I want Scratch Cat, and I'm actually right now I'm looking at the mouse to see how high this goes. It looks like y goes from 175 to negative 175. You can see that there. And x goes from about 235 to negative 235. So I'm looking at this go-to block, so please, eyes on my screen. If I ask Scratch Cat to go to 0, 0, that's the center of the screen. 150, 0, that's to the right. Negative 150, 0, that's to the left. Now if I make x 0, goes back to the middle, and I can change y. So 150, if y is 150, so 0, 150, he's high. If y is negative 150, he's low. What if I want Scratch Cat over here? That means I want my x to be a high number and my y to be a very negative number. So I would keep y at negative 150, but I would make x 150. Okay? I know that concept, that is actually a huge concept in math. And that is, it's okay if that does not quite make sense right now, but we're going to keep seeing that. I want you to kind of mess around with that as you think about it. But it basically, this y number, this number that you put into this kind of y category, is going to determine how high or low your sprite is on the page. And what you put into this x value is going to determine how right or left the cat is on the page. X is the horizon line, and Y is, yeah, it's like the vertical line. One X value is 1 pixel. That is correct. Okay. So at negative 200, Scratch Cat is very much to the left. And I am going to I want everybody in these last 10 minutes of class to create a dancing script. So I'm going to show you what I'm going to do first, and then I want you guys to do it. So I changed it so that it was negative 200. I made his steps really small. And he's going to walk kind of to the center of the screen. I want him to change costume to costume 2. And I can do that as a looks block. That's the switch to costume 2. And then I want him to kind of spin in a circle while moving backwards. And then spin backwards in the circle. So I'm just trying different things out. Like, what would this look like if I had him kind of move backwards? And I should have explained that before. If he moves negative 10 steps, that means he moves to the left. So what would that look like? You know, we're just kind of trying stuff out. He's kind of doing a little dance, and you could try it for a lot longer than 10. All right, and then maybe have him go the other way. And these are turn blocks within the motion. So first he was turning to the right, and now he is turning to the left. I want you guys to try out different blocks that you see. If there was time, I would let you try out different costumes, but and edit costumes, but I haven't been able to introduce that. But just try to get your Scratch Cat to do some different stuff. Ella, okay, so go ahead and do this. I'm going to leave this screen up so you can take a look at my code, but I want you guys to try out different dances. Ella, look at my screen for a second. You need to get this clear block. I'm under pen. You need to get this clear block and click it. This is just to Ella. Ella, I'm glad you were messing around, but I hope that you see the challenge that we're supposed to do right now. In about 2 or 3 minutes, if someone wants to share the dance that they did, they absolutely can. We'll have you share your screen. So try different stuff. Change color effect by 25. I wonder what that would do. Well, that's pretty cool. Right, you're just experimenting. Sarah, do you have a dance that you want to show? Sarah, raise your hand if you have a dance you want to show. Oh! You know what? I'm just realizing that these are on the Raspberry Pis, and we're not going to be able to share. So if you do want to share, you can take a video. That's the best I can do. It looks like it's not going to be super easy to share these, but you can post it on Edmodo if you get something really cool. Maybe these dances not so much, but sorry, Annika, you can't share unless... Annika, I'm going to unmute you because I have a question. Annika, are you doing this on a computer or your laptop or a Raspberry Pi? Or a desktop?
I'm on my Raspberry Pi, but I just if you do change color by 10 and you do the rotate, it rotates and changes all different colors while rotating.
Kind of like this? Do you mean like this?
Yeah.
Yeah, very cool. I really like that. Thanks. So Annika was just saying that within your loop, if you have it rotate and change color, maybe I think she wants it to change by 10. It changes while it rotates, which is very cool. Quite sure what changing this does. Interesting. Whoa! I'm enjoying myself, that's for sure. Alright, let's see if I can get a regular looking cat. I hate that we can't see everybody's stuff, but I hope you guys are enjoying it. You should try the change whirl effect. I will. Woo! Oh my gosh, that's perfect. That's perfect for the rotate. That's crazy. Okay, guys, enjoy Scratch. We'll continue on next week. You'll be adding your own costumes. I can show you that right now at the end of class, eyes on my screen. If you want to add or change one of these costumes, what you can do is right-click. Oh, you can just hit this copy. Now notice I have the same costume and I can double-click it. And you can add stuff, like I could add a little crown. Ooh, kind of went in the eyes. That doesn't look pleasant. Alright, so you can mess around with that, try to do different animations, just enjoy yourself. We will definitely do more of this next week. You can also add a new sprite from File. Everybody, eyes on my screen. See where I am right now? Between the stage and the sprites area. Click Add New from Style. I'm going to add this bat. And notice that all my scripts went away. Well, that's because each sprite has their own scripts. So now my bat, I can have him do his own crazy thing. When the green flag is clicked. And I will, he didn't really do that much. I will go over this again on Monday. I just wanted, for those of you who kind of wanted to mess around with stuff, I wanted you to see that at the end of class. Have a wonderful weekend, and I will see you all on Monday.